Hi everyone, today we'll discuss a problem on Laplace proof second shifting theorem or second translation theorem. We are going to prove it. So what is the statement? If f of t Laplace transformation f of t equal to f of s and g of t equal to given 0 g of t equal to f of t minus a when t is greater than a and 0 when t is less than a. Then Laplace transformation of g of t equal to e to the power of minus as f of s. This is the second shifting theorem. Now we're going to prove it. Prove the second shifting theorem. Okay, let's go. So let's prove. So what is given? Laplace transformation of g of t equal to left hand side we are taking is 0 to infinity from the definition of the Laplace transformation e to the power of minus st g of t dt. And g of t is a split function, signum function. So this is 0 to a e to the power of minus st g of t dt plus a to infinity e to the power of minus st g of t dt. We got it. Now the second part. Let me write down the second part. 0 to infinity e to the power of minus st a to infinity e to the power of minus st dt. What is g of t? When t is less than a. Less than a is 0. So it is 0. T is greater than a. What is this? F of t. G of t is f of t minus. F of t minus. G of t is 0. So 0 into anything is 0. Integration of 0 is 0. Now g of t is f of minus. So our problem reduces to, the part of our theorem reduces to a to infinity e to the power of minus st f of t minus a dt. Now what I am doing here, what I am doing here, t minus a equal to some variable x I am taking. So dt equal to dx. So dt has become dx. So dt equal to dx, no problem. Now lower limit. What is lower limit? A. That means t equal to a. A minus a equal to 0. X equal to 0. So lower limit is 0. Now for upper limit. What is upper limit? T equal to infinity. Infinity minus a should be infinity. So x tends to infinity, upper limit. Now our integration becomes a is becoming 0, infinity is infinity, e to the power of minus s. T minus a is x, so f of x. Dt has become dx, no problem here. For dt is becoming dx, no problem here. Now, what is our t? See here, what is our t? T equal to a plus x. So in the place of t, you have to write a plus x. That's it. 0 to infinity e to the power of minus as into e to the power of minus sx f of x dx. Variable is x, so you are keeping this variable part as a variable part as it is. This you are keeping outside. So e to the power of minus as 0 to infinity e to the power of minus s f of x dx. You have done, you remember? Do you remember? I think you remember. Smart people, you are engineers. So e to the, you see, integration a to b x square dx is same as integration a to b y square dy. That means limit of integration is same, integrand has same function, then the answer is same. It doesn't matter it is x or y square. Answer, both the answer will be the same. So therefore it is either x is there or t is there. Therefore it is e to the power of minus s f of s. That is the proof. Therefore, the Laplace, which is our right hand side. So, Laplace transformation of, you see, second shifting theorem. G of t dt equal to 0 to infinity e to the power of minus st g of t dt. It is an signum function. So, two parts. That means one function is having two phases. One phase is 0 when t is less than a. One phase is f of t minus a when t is greater than. Then they split the function into two parts, 0 to a to 0. 0 to infinity is there, we are taking the break here. 0 to a, then a to infinity. With that we got a, this is not in the standard form. To reduce in the standard form, we are taking another function, t minus a equal to x. With that, we change the dt to dx. The function changes, the constant taken out. Again, it is in the form of Laplace. This is the Laplace transformation. Is f of x. Or Laplace transformation f of t or f of x is f of s, which is our right hand side. Thanks for watching. This is second shifting theorem. I will make another video for the problems. Okay. Thank you once again.